Hello students, welcome to Shri classes. This is the last lecture where we are going to see some questions from exemplar book. So already it is displayed here. There are too many questions here. Let us see, maybe if possible I'll try to go through all, or some of the questions can be given as an assignment also. I hope you are able to see very clearly. Let me check it. Let me increase it to 200% and see. Yeah, I think it is much better now. Okay, fine. MCQs. Let us start now. Very quickly I'll rush through. Not much explanation. Already explained in detail in the theory. I'll be trying to concentrate on the answers, and also we'll try to check the answers. What happens when a solution of an acid is mixed with a solution of a base in a test tube? Temperature of the solution increases? Yes. Temperature of the solution decreases? No. Temperature of the solution remains same? No. Salt formation takes place. 1 and 4. Therefore, 1 and 4. D is the correct answer. Next. An aqueous solution turns red litmus solution blue. Means red to blue means it should be alkaline. Excess addition of which of the following solution would reverse the change? So it is a base basically. An aqueous solution turns red litmus blue means it is base. Correct? Red to blue, it is base. Which of the excess solution, which of the addition of the following solution makes the reverse? That is blue to red means acid should be added. So which are the acids? Baking powder, base. Lime, it is acid. Ammonium lime is, even though citric acid it contains, you must read further options and then conclude. Ammonium hydroxide, base. Hydrochloric acid, strong acid. So hydrochloric acid is the answer for this. Lime is basically citric acid which is not powerful acid, it's a weak acid. Therefore D is the answer. Next. During the preparation of hydrogen chloride gas on a humid day, the gas is usually passed through the guard tube containing calcium chloride. The role of the calcium chloride taken in the guard tube is to absorb the evolved gas? No. Moisten the gas? No. Absorb the moisture from the gas? Yes. Absorbs chloride ions from the evolved gas? No. Remember, in the activity there is a small guard which contains calcium chloride. Calcium chloride acts as a drying agent. On a humid day, it absorbs the moisture and therefore absorbs the moisture from the gas, and the dry gas comes out. Answer C is the correct answer. Fourth one. Which of the following salts does not contain water of crystallization? Blue vitriol contains. Baking soda does not contain. Washing soda contains. Gypsum contains. Baking soda. B is the answer. Next. Sodium carbonate is a basic salt because it is a basic salt means strong base. Check wherever strong base, weak acid. Strong acid, strong base, no. Weak acid, weak base, no. Strong acid, weak base, no. Weak acid, strong base. Yes, answer D is the correct answer. Next. Calcium phosphate is present in tooth enamel. Its nature is basic in nature. A is the answer for this. Next. A sample of soil is mixed with water and allowed to settle down. The clear superannuant solution means after settling whatever the solution remains, that is called superannuant solution, turns the pH paper yellowish to orange. Yellowish to orange means it is acidic in nature. Which of the following would change the color of this pH paper to greenish blue? Greenish blue means it is neutral range. In the pH paper that you study in your book, it is given. Okay, pH paper diagram, in that you can find the different colors. Yellowish orange soil content is yellowish orange means the soil is acidic in nature, and it should be brought to greenish blue. So which of this following will change that one? Lemon juice? No. Vinegar? No, because both are acids. Common salt? Common salt is a neutral salt. You must remember, no effect. An antacid? Yes, baking soda. So baking soda is antacid baking soda acts as an antacid, no? So antacid is the one which will bring the yellowish orange color of the solution to greenish blue. Answer is D. Next. Which of the following gives the correct increasing order of acidic strength? Weak to strong. Water is weak acid. Water is not at all acid. Acetic acid, weak acid, hydrochloric acid, strong. This itself is the correct answer. All other, because it is important here, you can read the other options. A is the correct answer. Next. Few drops of concentrated acid accidentally spills over the hands of a student. What should be done? If it is an acid, apply mild basic something. So if that option is there, wash hand with saline solution. No, salt solution is very dangerous. Wash hand immediately with plenty of water and apply a paste of sodium hydrogen carbonate. Yeah, this is the answer. Why it is so? Wash hands so that excess acid goes off, and hydrogen carbonate is a base that nullifies the effect of concentrated acid and gives relief. Next, 10th one. Sodium hydrogen carbonate, when added to acetic acid, evolves a gas. Which of the following statements are true about the gas? See here, sodium hydrogen carbonate is a carbonate, and acetic acid, it reacts with acetic acid. How do hydrogen carbonates and carbonates react with acids? They evolve CO2 gas. Is it there? And CO2 gas turns lime water milky. So, which of the following statements are true about the gas evolved? It turns lime water milky? Yes. It extinguishes burning splinter? Yes, CO2 extinguishes. It dissolves in a solution of sodium hydroxide? Yes, it dissolves in a sodium hydroxide. It has a pungent odor? No. 1, 2, 3 are correct. 1, 2 and 3. Answer B is the correct answer for this. Okay. Can we go to the next one? Common salt, besides being used in kitchen, can also be used as the raw material for making washing soda, bleaching, baking, slate lime. Indirectly, all these are used, but you must specifically pick up. Washing soda, yes. Bleaching powder is also yes, but let me check it. Baking soda, yes. Slate lime, no. 1, 2, 3 should be the answer. If not, at least 1 and 3 should be there. Let me check. 1, 2, 4, 1, 3, 4, 1 and 3, 1 and 2, 1 and 3, 1 and 3. C is the answer for this. Okay. Next one. One of the constituents of baking powder is sodium hydrogen carbonate. Correct. The other constituent is tartaric acid. Answer is B. To protect tooth decay, we are advised to brush our teeth regularly. The nature of the toothpaste commonly used is basic in nature. Next, which of the following statements is correct about an aqueous solution of an acid and a base? Higher pH aqueous solution of an acid or a base. Which of the following statement is correct about an aqueous solution of an acid and of a base? First acid, then base. Higher the pH, stronger the acid. Wrong. Higher the pH, weaker is the acid. Yes, higher the pH value, weaker is the acid. Lower the pH, stronger is the base. Yeah, that is also true. Lower the pH, lower the pH, stronger is the base. Wrong. Higher the pH, stronger is the base. Lower the pH, weaker is the base. Lower the pH, weaker is the base. So, higher the pH, weaker is the acid. Lower the pH, weaker is the base. 2 and 4. 2 and 4. Answer D is the correct answer. pH of gastric juices released during digestion is less than 7. First one. Which of the following phenomenon occur when a small amount of acid is added to water? Ionization takes. No neutralization. Dilution takes. Salt formation? No. Ionization and dilution. 1 and 3. 1 and 3. B should be your correct answer. Next. Which of the following can be used as an acid base indicator by visually impaired students? Visually those are impaired. So what is that you can use it? Vanilla essence, litmus turmeric petunia leaves require people with visibility. So vanilla essence, odor, and therefore C is the answer. Which of the following substances will not give carbon dioxide in treatment to dilute acid? Marble is a calcium carbonate, it gives. Limestone is a calcium oxide. Will it give? No. Baking soda is a sodium hydrogen carbonate, it gives. Lime is calcium hydroxide and it turns milky. So marble, limestone, baking soda, lime. Out of this one, which one will give? See, marble and limestone both are same. Both are same. So lime is the one which is calcium hydroxide solution, and therefore lime will not give you carbon dioxide on treatment with acid, whereas marble, limestone are same, which is nothing but calcium carbonate, and that will give you CO2 gas. And baking soda is sodium hydrogen carbonate, that also gives with acid baking CO2 gas. Lime is lime water means what? It is a sodium hydroxide solution. Not sodium, calcium hydroxide solution. It will not give the CO2 gas. So answer is, let us see here, D. Which of the following is an acidic in nature? Lime juice? Yes. Human blood? No. Lime water? No. Antacid? No. Acidic in nature is lime juice, A. So, in an attempt to demonstrate electrical conductivity through an electrolyte, here sodium hydroxide solution is taken. Okay, the following apparatus was set up. Which among the following statement is correct? Bulb will not glow because electrolyte is not acidic. Sodium hydroxide. Bulb will not glow because electrolyte is not acidic. It is, which of the following statements are correct? Wrong it is. Bulb will glow because NaOH is a strong base and furnishes ions for conduction. Right, it is correct answer. Bulb will not glow because circuit is incomplete. Wrong. Bulb will not glow because it depends upon the type of electrolytic solution. Bulb will not glow because it depends upon the type of electrolytic solution. So 2 and 4 are correct. Which of the are correct? 2 and 4. 2 and 4. Answer B is the correct one. Is it one? Check it. In an attempt to demonstrate what the following was set up, which among the following statements are correct? Bulb will not glow because electrolyte is not acidic. Wrong. It is not correct. Correct is bulb will glow here because sodium hydroxide is a strong base, and bulb will not glow because circuit is incomplete. That's also wrong. It is circuit is complete. So correct statements are bulb will not glow because it depends upon the type of electrolytic solution. No, here bulb will glow. Answer is 2 only. Out of this, 2 only is the correct answer. See, dear students, here there is one problem. He has given both as C options here, but remember, out of this correct statement I am picking up. Please listen carefully. Bulb will not glow because electrolyte is not acidic. It is wrong, because sodium hydroxide is taken here and it will glow. First statement is wrong. Bulb will glow because NaOH is a strong base and furnishes ions for conduction. True. Bulb will not glow because circuit is incomplete. False. Bulb will not glow because it depends upon the type of electrolytic solution. False, because bulb glows here. So only 2 is the correct answer. This C is correct answer. This C is wrong answer. So this C we have to go for. Next. So, which of the following is used for dissolution of gold? For dissolution of gold, please remember, see, the gold is soluble only in a particular mixture called aqua regia, which you are going to study in metals and non-metals. Even though the acids are very strong, gold cannot be dissolved in strong acids such as hydrochloric or sulfuric acid or nitric acid. But aqua regia is a mixture of acids in which it will dissolve. So we will discuss this in metals and non-metals. Which one of the following is not a mineral acid? Hydrochloric acid, sulfuric acid, nitric acid are mineral acids. Not a mineral acid, citric acid. B is the answer. Which among the following is not a base? Sodium hydroxide is a base, KOH is a base, ammonium hydroxide is a base, C2H5OH is ethanol. Therefore, this is not a base. Answer D. Which of the following statement is not correct? A metal carbonates reacts with acid to give a salt, water and carbon dioxide. Correct. It is correct. All metal oxides react with water to give salt and acid. Some metals react with acids to give salt and hydrogen gas. Some non-metal oxides react with water to form an acid. Which of the following statements is not correct? All metal oxides react with water to give salt and acid. How it is possible? This is incorrect. B is the answer, correct answer. Match the following here. Bleaching powder, preparation of the glasses, production of H2 and Cl2, decolorization, antacid. Okay, bleaching powder, decolorization, baking soda, antacid, washing soda, preparation of glass, sodium chloride, production of H2 and Cl2. These are the answers for your thing. So bleaching powder, it is used for decolorization, A and 3, and baking soda, it is used as an antacid. Washing soda in the preparation of the glass industry, paper industry, etc. And sodium chloride is used production of H2 and Cl2 by chloralkali process. So D and 2 is the correct. So let me check what answers we have to find out here. A3. Where is A3? Here, A3. Okay. What he has given? Okay. So these are 4 options. A is this option, B is this option, C is this option, D is this option. We have to select here. Now A3, in the beginning itself, A3 there are 2 options. A3, let me check this option. A3 correct, B 4. This is wrong. A3, B4, C1, sodium chloride 2, D2. So answer is C here. Equal volumes of hydrochloric acid and sodium hydroxide solution are taken. Solutions of same concentration are mixed, and the pH of the resulting solution is checked with a pH paper. What would be the color obtained? Strong acid, strong base. It is going to be a neutralization reaction. I can find these 2 colors. What is this? Yellowish green. Let me check whether it is there or not. Yeah, answer C, yellowish green is the answer for this. Next, which of the following are true? True, we have to pick up. HCl gas is passed through water. It does not ionize in the solution as it is covalent compound. Wrong. It ionizes, yes. It gives both hydrogen and hydroxyl ion in the solution. Yes, it will give hydrogen and hydroxyl ion. No, it will give hydrogen and chloride. It forms hydronium ion in the solution due to combination of hydrogen ion with water molecule. According to me, 2 and 4, answer C is correct. It will not give hydroxyl ions there, hydrogen and chloride, but next option is hydronium, and I hope you have understood. Next one. Which of the following statement is true for acids? Acids are sour and they turn sour and blue litmus to red. C is the answer. Acids are sour and change the blue litmus to red. Next. Which of the following are present in dilute aqueous solution of hydrochloric acid? H3O plus and Cl. This is definitely okay. Not okay, not okay. This is first is the answer. Unionized HCl, no, it undergoes complete dissociation. So H3O plus and chloride ions, hydronium ions plus chloride ions are present. A is the correct answer. Next, identify the correct representation of the reaction during the chloralkali process. Chloralkali process. This appears to be correct. NaCl plus 2H2O. Oh, balancing we have to check it everywhere. That you do yourself, because you have to check the balancing and then answer it. Okay, so short answer type questions. So we'll continue again with this short answer types of questions. Okay, so far we have seen MCQ type questions. Let me take up now short answer questions. Match the following: lactic acid curd, acetic acid vinegar, citric acid lemon, oxalic acid tomato. Clear? Go to the next question. Match the important chemicals. Okay, here also. What is given here? Chemical formulae and common name. Plaster of Paris, CaOCl2. Is it there? CaOCl2. Calcium oxychloride. Gypsum, calcium sulfate dihydrate. Calcium sulfate into 2H2. Here it is. Gypsum, calcium sulfate into 2H2. Bleaching powder, calcium oxychloride, CaOCl2. Where is that? Bleaching powder. What did I say first one? Plaster of Paris. Plaster of Paris, did I say calcium oxychloride? It is wrong. Dear students, let me address this once again. I think I must have made a mistake. I am not sure. I'll check here. Plaster of Paris is calcium sulfate hemihydrate, CaSO4 into half H2O. Sorry, I think I made a mistake. Plaster of Paris is calcium sulfate into half H2O, which is calcium sulfate hemihydrate. Gypsum, calcium sulfate dihydrate. Bleaching powder, calcium oxychloride. Slate lime, calcium hydroxide solution. Perfect. What will be the action of the following substances on litmus paper? What litmus paper? Blue or red? Not given. Okay. Dry HCl gas. No action, because dry HCl gas will not dissociate into ions, H plus ions, and hence it will not show acidic character. No action on the litmus paper. Moistened ammonia gas. Ammonia is basic in nature, turns red litmus blue. Lemon juice, acidic in nature, turns blue litmus red. Carbonated soft drink. See, very important. Carbonated soft drink means CO2 plus water. CO2 plus water. What is the CO2? Nature of CO2? Non-metallic oxides. Non-metallic oxides are acidic in nature, and therefore CO2, when dissolves in water, carbonic acid is formed, H2CO3, and therefore carbonated soft drink contains carbonic acid, turns blue litmus red. Curd contains lactic acid, turns blue litmus red. Soap solution is basic in nature, turns red litmus blue. Next, name the acid present in the acid present in an ant sting and give its chemical formula. Name of the acid present in the ant sting is formic acid, which is also called methanoic acid. Formic acid is a common name and methanoic acid is an IUPAC name, International Union of Pure and Applied Chemistry, IUPAC name. So methanoic acid's formula is HCOOH. Also give the common method to get relief from the discomfort caused by the ant sting. Use a solution of mild antacids such as baking soda, which is basic in nature. It will neutralize the effect of acids, that is formic acid, and thus gives the relief. What happens when nitric acid is added to eggshell? Eggshell contains calcium carbonate. When nitric acid is added, calcium nitrate, and what is formed? Very important, dear students. Here egg nitric acid and all, what is that is important observation here is calcium nitrate plus CO2 plus water. How do carbonates react with acids? Carbonates react with acid to form salt, water and CO2 gas. Here what happens when nitric acid is added to eggshell? Brisk effervescence of CO2 gas is evolved. Somebody had asked me the question, what is brisk effervescence? Brisk effervescence means rapid evolution of gas. Are you able to understand? For example, I can compare the brisk effervescence with fizzing. Like the soda bottle or the Coca-Cola bottle, if you shake it and open, that is what it is called, fizzing basically, isn't it? So brisk effervescence is rapid evolution of the gas. So I answered this question. CO2, brisk effervescence of CO2 is formed. A student prepared solutions of an acid and a base in two separate beakers. She forgot to label the solutions and litmus paper is not available in the laboratory. Since both the solutions are colorless, how she distinguishes between the two? If she forgot to bring the litmus paper, use turmeric powder or use phenolphthalein or use methyl orange or use methylene blue, isn't it? All these are the indicators. Or use some colored petals, China rose petals, petunia, geranium, etc. You can use so many other indicators, not necessary to identify acids and base. You require only litmus paper, not required, no? You can use all those things. So that is the answer for that. How do you distinguish between, I think 36 is over, 37. How do you distinguish between baking powder and washing soda by heating? Yes. Let me draw the equation here. Let me write the equation for this. Yeah, question is, how do you distinguish between the heating action on baking powder? Baking powder contains NaHCO3. On heating, sodium bicarbonate undergoes thermal decomposition to produce Na2CO3 plus CO2 plus H2O. This is what it is. So, on heating sodium bicarb, you get brisk effervescence of CO2 gas here, and this CO2 gas rises in the dough and makes the bakery products soft and spongy. Now question is, washing soda Na2CO3 into 10H2O, if we heat it, what is that we get it here? It loses water of crystallization molecule, and from crystals to powder it will change. Na2CO3 plus H2O, 10H2O. Okay, this is a powder here. How do you distinguish here? The distinction is this factor, carbon dioxide. By heating NaHCO3, evolution of CO2 gas is observed, which in turn turns the lime water milky, whereas such evolution of gas is not observed in this case, in heating of washing soda. That is the answer. Let's go to the next question. A salt A is commonly used in bakery products. On heating, gets converted into another salt B, which itself is used for removal of hardness of water, and gas C is evolved. The gas C, when passed through the lime water, turns it milky. Identify A, B, C. Salt A, bakery products. So salt A is baking soda. Is it right? Baking soda. A is NaHCO3. On heating, it is converted to another salt B, Na2CO3. The same thing which I had written in my previous Na2CO3, which itself used for removal of the hardness of water. Correct? No? Yes, Na2CO3 into 10H2O, which is washing soda. It is used to remove the permanent hardness of water. So salt B is Na2CO3 and hardness of water, and gas C is evolved. So when A is heated, this is produced and C is evolved. C is carbon dioxide. So salt A is NaHCO3, B is Na2CO3, C is CO2 gas. The gas C, when passed through the lime water, it turns milky. Yes, CO2 gas, when it is passed through the lime water, it turns milky. Identify A, B, C. A, NaHCO3, B, Na2CO3, C, CO2 gas. Next. In one of the industrial processes used for the manufacture of sodium hydroxide, a gas X is formed as a byproduct. The gas X reacts with lime water to give a compound Y. Okay, it reacts with lime water to give a compound Y, which is used as a bleaching agent in the chemical industry. A compound Y is used as a bleaching agent, bleaching powder. So, how do you obtain bleaching powder? The gas X reacts. Which gas? Chlorine. Chlorine gas reacts during a chloralkali process, that is the production of sodium hydroxide, and therefore X is Cl2, Y is calcium oxychloride, and what else? Identify X and Y giving the chemical equations of the reactions involved. I am writing chemical equations now. 39th. How do I read? Used to manufacture sodium hydroxide, a gas X is liberated. NaOH, sodium hydroxide, NaCl plus H2O, okay, gives you NaOH plus Cl2 plus H2O. It is not balanced. I'll have to refer to the book for balancing, or let's check it now. This is chloralkali process. This is electrolysis of brine solution here. So sodium hydroxide is one of the product, and here this is chlorine gas. See, this chlorine gas is the gas X reacts with, this is the X gas. Okay, it reacts with calcium hydroxide CaOH2 plus Cl2 gives you CaOCl2 plus H2, isn't it? So this is bleaching agent. Bleaching agent. So this is Y here, compound calcium oxychloride, and X is chlorine gas. Let us try to balance this. NaOH Cl2 here, 2 NaCl, so 2 NaOLs, 2 H2O. It is balanced. 2 oxygen. It is balanced. This is how it is. So remember, these are the two chemical reactions. Identification: X is the chlorine gas and Y is the bleaching agent. So can we go to the next question now? Yeah. Okay. Question number 40. Fill in the missing data in the following table. Salt, formula, base, acid. So this salt is formed by the reaction between acid and base. We have to identify this either acid or a base to form this as a salt. Ammonium chloride, NH4Cl. It is ammonium hydroxide and HCl. NH4OH plus HCl gives you NH4Cl plus water. So what is the use here? HCl. Second, copper sulfate is formed here. Formula is CuSO4 is the form. Copper sulfate is formed. How do you get this one? Copper hydroxide plus sulfuric acid gives you copper sulfate plus H2. So dash here is copper sulfate CuSO4. Here it is CuOH twice. Next, sodium chloride NaOH plus HCl. Next, magnesium nitrate HNO3 is used, magnesium hydroxide MgOH twice. K2SO4 here, base and S. Acid is sulfuric acid H2SO4, and KOH plus H2SO4 gives you K2SO4. Then calcium nitrate, calcium hydroxide plus nitric acid gives you HNO3 here, nitric acid gives you calcium nitrate. What are strong and weak acids? Already defined. In the following list of acids, separate strong acids from weak acids. Hydrochloric acid, mineral acid, strong acid. Citric acid, organic. Acetic, organic. Nitric, organic acids are weak acids. They partially dissociate into ions, and mineral acids are strong acids. They completely dissociate into ions. So it's a hydrochloric acid, strong acid. Citric, acetic, weak. Nitric, strong. Formic, weak. Sulfuric acid, strong. Next, when zinc metal is treated with dilute solution of a strong acid, a gas is evolved. Hydrogen gas is evolved, which is utilized in the hydrogenation of the oil. Yes, hydrogen produced is used in the hydrogenation of oil. What is hydrogenation of oil? Conversion of unsaturated vegetable oils into saturated vegetable ghee is called hydrogenation, which we'll be studying in carbon and its compounds. Okay, so hydrogen is used in conversion of unsaturated vegetable oils to vanaspati, dalda. Okay, something like that. So name the gas evolved. Hydrogen is evolved. Write the chemical equation of the reaction involved. Zinc plus HCl, zinc ZnCl2 plus H2. And also write a test to detect the gas formed. When you bring a burning matchstick or a burning candle near the mouth of a test tube containing hydrogen gas, it burns with a pop sound. Next, long answer questions. Yeah, here in the following diagram, preparation of the hydrogen gas is shown in figure 2. What would happen if the following changes are made? Kidhar are changes? Oh, you'll have to read the bottom. What is given first? Let's see. Sulfuric acid, zinc granules. We have taken zinc granules and sulfuric acid. Clear? Hydrogen gas is evolved. Okay. What are the changes? In place of zinc granules, same amount of zinc dust is taken in the test tube. Zinc granules and zinc dust. Dear students, tell me, if any chemical reactions has to take place, then the more contact should take place between the reactants. Between the zinc granule and the zinc dilute sulfuric acid, between the zinc granules and the sulfuric acid, is there a more contact? Or in zinc dust means zinc powder, in zinc powder and sulfuric acid is the more contact? Where do you expect more contact? Where do you expect more contact? See, for chemical reactions to take place effectively, if the reactants are, one of the reactants is in a powder form and the other is in solution form, the maximum contact between the reactants take place, and therefore the evolution of hydrogen gas is faster when zinc dust is taken compared to the zinc granules. Is that clear? Instead of dilute sulfuric acid, dilute hydrochloric acid is taken. Zinc granules and dilute hydrochloric acid. Same observation. Hydrogen gas is evolved. In place of zinc, copper turnings are taken. Copper being lower than the reactivity, lower in the reactivity series than hydrogen. Copper would not be able to displace hydrogen from the acids. No reaction takes place. Sodium hydroxide is taken in place of dilute sulfuric acid and the tube is heated. Good. Some metals reacts with bases such as aluminum and zinc, and those are called amphoteric metals, and therefore sodium zincate with liberation of hydrogen gas is observed. Okay, these are the things. Next, for making cake, baking powder is taken. If at home your mother uses baking soda instead of baking powder in the cake, how will it affect the taste of the cake and why? Oh, baking powder is taken for making a cake. Suppose your mother uses only baking soda than baking powder, how will it affect the taste of the cake and why? Okay, baking powder is a mixture of baking soda and tartaric acid. Okay, if your mother uses only baking soda, it undergoes thermal decomposition to produce CO2 and Na2CO3, isn't it? Na2CO3 is a bitter in taste, and therefore the cakes taste bitter if baking soda is used. How can baking soda be converted into baking powder? By adding in suitable proportions tartaric acid. What is the role of the tartaric acid added to the baking soda? As I have already discussed, tartaric acid, Na2CO3, which is produced after heating baking powder, to nullify the effect of base Na2CO3, tartaric acid is the acid, and between the acid and base the reaction is a neutralization reaction, and therefore it will neutralize the action of the base, and hence the cake will not taste bitter but normal taste. Next, a metal carbonate X on heating, on reacting with an acid gives metal carbonate X. Remember, on heating with an acid gives a gas when passed through a solution Y, gives carbonate back. On the other hand, a gas G that is obtained at the anode during electrolysis of brine is passed on dry Y. It gives a compound Z used for disinfecting drinking water. Identify X, Y, Z and G and Z. Such questions in my I had given one assignment, science assignment 13. In that, question number 9 and question number 17, I think some of these questions are similar to this one. These things you have to read extremely carefully, slowly, word by word, use your knowledge, and then you should be able to answer. So how do you find out? A metal carbonate X on reacting with an acid gives a gas. You know already, metal carbonate when reacts with acid, it gives CO2 gas. A CO2 gas which when passed through a solution Y gives carbonate back. That means this CO2, when it is passed through, I know very well, when CO2 is passed through calcium hydroxide solution, I get carbonate back. So a metal carbonate X here is calcium carbonate. I hope you are able to understand. And when it reacts with acid, it gives a CO2. So calcium carbonate is X. When it reacts with acid, it gives Y, which is a solution, a gas CO2, not Y, a gas CO2. When it is passed through a solution of Y, Y here is calcium hydroxide. So metal carbonate is X is calcium carbonate and Y is calcium hydroxide to get calcium carbonate back. On the other hand, gas G is CO2 gas which is obtained at the anode during, on the other hand, gas G that is obtained at anode during electrolysis of brine. Where do you obtain gas G during anode? Gas G is not CO2 here. Gas G is anode. What is electrolysis of brine? hydrogen and chlorine gas are evolved. Chlorine is anion and therefore anions migrate towards anode, and therefore gas G is chlorine gas here. So chlorine is G is chlorine when it is passed through during electrolysis of brine is passed through or passed on dry Y. Dry Y means CaOH2 here. When Cl2 is passed over dry Y, it gives a compound Z, calcium oxychloride. You understood? CaOCl2. So X is calcium carbonate, Y here is calcium hydroxide, gas G liberated at anode is Cl2 gas, action of G on a dry Y, action of chlorine gas on dry slate lime gives you Z, calcium oxychloride, CaOCl2. Therefore X is CaCO3, Y is CaOH twice, G is Cl2 and Z is CaOCl2. Chemical reactions you do yourself. Next, a dry pellet of common base when kept in open absorbs moisture and turns sticky. A dry pellet of common base, see this property of absorption of the moisture and turning into sticky is called, this process is called hygroscopic. What is hygroscopic? Some salts absorb moisture and they turn into sticky mass. You got it? Those are called hygroscopic. So a dry pellet of common base when kept in open absorbs moisture and turns sticky. Okay, the compound is also a byproduct of chloralkali process. Base product of chloralkali process, it is sodium hydroxide, isn't it? So identify B. So B is sodium hydroxide. What type of reaction occurs when B is treated with an acidic oxide? See, acidic oxides are acidic oxide, example CO2. Acidic oxides are what are acidic oxides? CO2, SO2, NO2, etc. These are all acidic oxides. What are acidic oxides? I will define now. Non-metallic oxides are called acidic oxides. So what type of reaction occurs when B is treated with an acidic oxide? B is base, acidic oxide. Acid plus base gives you salt and water, isn't it? Therefore NaOH plus CO2 gives you Na2CO3 plus water. This is what is the answer. Write a balanced chemical equation. You do yourself that one. So what is the reaction over here? NaOH plus CO2. Understood? So CO2, Na2CO3 is the product which is formed, and also water. A sulfate of group 2 element in the periodic table. When it is periodic table, then I'll discuss in the next after completion of the periodic periodic table chapter. Identify X on the basis of the reactions given below. Okay. Also write the name and chemical formula of ABC. Compound X, zinc, A plus hydrogen gas. Compound X is definitely should be some acid, because acids plus zinc metals gives you A and H2 gas. So let us find we'll check all these things, then we'll see. Zinc here, compound X. Identify compound X on the basis of the reactions given below. Also write the name of the chemical formula ABC. Okay, let us try. Zinc plus HCl gives you, let me check, compound X and HCl, no, CH3, it must be base here, because HCl and this base will give you a water. This must be a base and acid. This acetic acid gives you a water, therefore this should be a base. If it is to be a base here, I can consider this to be NaOH. NaOH plus Zn gives you Na2Zn-O. I think Na2Zn, Na-Zn-O2. It should be sodium zincate. I don't know what is that one. Na2Zn-O2. Na2Zn-O2 is sodium zincate. So here compound X is sodium hydroxide plus zinc gives you Na2Zn-O2 sodium zincate plus hydrogen gas. NaOH plus HCl gives you NaCl plus H2O. NaOL plus CH3COOH gives you CH3COONA sodium acetate plus H2O. A is Na2Zn-O2 sodium zincate. B is NaCl sodium chloride. C is CH3COONA sodium acetate. These are this thing. Okay, so I think we completed the exemplar questions. Please work hard, study hard. Thank you very much.